Control of the generator output voltage is affected by adjusting the magnitude of excitation current. We already know that increasing excitation results in an increase in the strength of the rotating magnetic field. This, in turn, brings about an increase in the voltage, which is induced into the stator conductors. Let's take a closer look at the excitation system to see how this control is carried out. First, we'll look at a simplified arrangement of the static excitation system. DC current from the rectifier is supplied to the rotor winding through collector rings on the shaft. The incoming AC to the rectifier is supplied from a dedicated transformer. The primary side of this transformer is fed from an auxiliary bus, or in some cases, the generator bus itself. The sine wave for the incoming three-phase AC voltage, which is applied to the rectifier, will look like this. After rectification, the DC output can be represented by this curve, and this may be further smoothed to look like this. The level of DC voltage can be adjusted by controlling the firing of a thyristor-type rectifier. The firing circuit is controlled by the field voltage regulator. This regulator has two inputs, manual and auto. The manual control disconnects the automatic function and allows the operator to directly control excitation. However, when the generator is in operation, the field voltage regulator is usually controlled from the auto position, that is, from the AC voltage controller. This controller monitors the generator bus output voltage through VTs and automatically adjusts excitation to maintain the set point voltage. The operator can adjust this set point and thus exercise control while the excitation system is operating in auto. All of these components of the static excitation system are normally located in the excitation panel close to the generator. Of course, the auto and manual control inputs are also located on the operator's panel. Another type of excitation system often used is known as the brushless exciter. The exciter is actually a small AC generator which is built on the end of the generator shaft instead of collector rings. In this exciter, a stationary magnetic field is provided from the DC winding, which is wound on the stator. The rotor winding produces AC voltage, and this is fed directly into diode-type rectifiers, which are built into the shaft. So we have, in effect, a rotating rectifier. The DC output from the rectifier is connected directly to the main rotor winding through leads which pass inside the shaft. There is no need for collector rings or brushes. Control of the DC excitation current is affected by adjusting the strength of the exciter magnetic field, and this is done by controlling the DC current flow through the field winding. This DC field current is supplied from a rectifier which is located in a nearby cabinet. Of course, this rectifier is much smaller than the static rectifier that we previously studied because it is only supplying field current to the rotating exciter. However, control is affected in the same manner. That is, by adjusting the firing of the thyristors, and this in turn is governed by the field voltage regulator. The arrangement at this point is similar to the static exciter. When in auto, the field voltage regulator receives its command signal from the AC voltage controller, which in turn monitors the output voltage of the generator. The operator can adjust the AC set point as required. When starting up the unit, the field voltage regulator may be set to manual, and in this case, the operator will control the regulator directly.